assume they've already said something, or
or they just kind of get out of the touch with the technology.
Yeah.
That's a lot. Like I've been doing it this way for.
Yeah,
Like
I still
he actually
have
he
emailed them,
he
but
he demanded to have a chalkboard and chalk because he preferred that to whiteboard.
Aw.
Yeah. Yeah. So you have that balance. Okay, so let's just kind of wrap up where we're at real quick. The review has been posted to Blackboard. The review, I've put the answers at the so it looks class. Does anyone need an extra copy? 1 or 2 extra copies? I have 2, 3. Anyone else?
I thought there were actually problems.
Oh no, so online, if you open it, send to OneNote, print. So this is what I gave you guys in class. The one that is center, the vertices, the given equation. I printed out, but the ones on it's the same printout for the first answers. Did you get? I gave it. That's on the sign sheet. Yes. So this is actually far as middle. B. It's going to be ellipse, a hyperbola, or prop. And within each section, there's complete the square. So there's kind of only a few. Really highlight topics, you know, if you can do those 3 things, like 30% of the test. And then the other 50% of the test is just identifying and maybe completing the square. Question?
Alex, right off the bat, I was using a different formula for graphing.
To graph it?
Oh my God.
Yeah, it's weird. It wants you to find the vertex and then 1 point on the curve. I don't know why it has you do that. What do you mean different formula?
Y equals A times X minus H quantity squared plus K. Y equals A times X minus H quantity squared plus K.
Plus K? They want you to put it that way?
That's what they asked me to do.
Yeah.
In standard form, in the pie?
Yeah.
Right? Not in the homework?
In the homework too, right?
Yeah.
I don't remember, because I did them in class. I did all the homework
Trying to figure out
in
why.
class. So this is the same thing. This would just be K equals 4P X minus. It's the same thing. Generally, we want an equation to be Y equals a function of X. So we'll want Y on one side and everything else on the other side. Here they're calling A 4P.
Okay, so it's equivalent.
Yeah, it's equivalent. A is just a variable. Or not a variable. A is a constant. Sorry. What?
I don't know why, but A makes more sense.
Then 4P.
No, that's not.
A is just the placeholder for the coefficient in front of the x squared term. But the coefficient in front of the x squared term means something. A here is going to be the length of the focal diameter. P is going to be the distance from your vertex to your focus, your vertex to your dextrous line.
See, that's what I think P stood for, so we need the P variable.
No, P is just useful in calculating the focus and dexterous line, finding it.
Versus
A is just a placeholder. So of course 4 times P is A. 4P is also a placeholder. It's just broken down a little more to be able. And here it's a lot easier to see the shift in Y than it is here. But typically we write Y as a function of X. So we want Y on one side and everything else on another side. So that's why probably this is what they want you to put your final answer in. But going to graph it, this is much more favorable to see what the focus point is, what is the diameter of the lattice rectum, what's the endpoints of the lattice rectum, because if the diameter is 4, the endpoints are going to be 2 units to the right and 2 units to the left of the focus point. Right, so these are all these processes to go through. If you've missed class, then you know you're like I so if you, it's going to send YouTube link. Of course, it's the whole lecture recorded in class. So if you have also the print off of the notes, it's right here. Like I'm really struggling on complete the square. You can go to that part of the lecture and watch how we completed the square on those 4 or 5 problems. So, you know, kind of going to review, you're going to have to identify an ellipse, hyperbola, or parabola. What is the vertex? In completing the square. So I won't have you go through all the graphing. There will be completing the square there. No. If you put it in standard form, and that's as long as you come up with the right conclusion of the vertex, which is the you stop. I mean, you'll give one of the terms. If you get the vertex as a matter, I'm not going to be. In a college algebra course, we like to put y equals a function of x. Here, it's not as favorable because we don't see that vertex as easily, but it's not possible. If you're correct, I'm not going to dock you. Here, this is just easier to see what P is, what the vertex is, if I go up or down, left or right, things like that.
That's why I didn't understand P at all, because in Alex
It doesn't say anything about P, it's just A. But A is 4 times P, or A is the focal diameter. We don't necessarily care about the focal diameter as we can't find the focus point.
And if it was a -2 up there, how you did the 4.5, would you put the negative in front of the 1/2?
Well, the negative just means it opens left or right or up or down.
In front of the 4,
yeah, you could, yeah. P is up or down, right? Because the focus is up or down depending on if it's opening up or down. And then the opposite direction is the dexterous line. Okay. Yeah, so, you know, I don't think it's going to let me a video when I'm trying to record a video, but I'm having some issues. Yeah. So this one it let me open. Okay. Identifying, that's going to be something that will be on the test. Like to identify, you know, this is going to have, this is a ellipse with the major axis being the y-axis, right? So if I have a bunch of matching, you know, if I have an ellipse here, parabola, hyperbola, if I have all these matching, the only one this is going to match to is this, right? This is an ellipse with the y-axis being the major axis. 4 versus 3. Yeah, because the larger number's under the y, right? And then C for an ellipse is going to be C squared is A squared minus B squared, where A is the larger number. But in a hyperbola, the C for the focus point is going to be A squared plus B squared. C is a squared plus b squared. So it doesn't really matter which is a and b, right? Because you're adding them. And then the ellipse P, we've talked about it being here. This is the P for the ellipse, or the focus point. It's P units up, P units down, right? The ellipse and the hyperbola are very similar form. Only one of them has a negative or a positive, right? So this one's going to open left or right. The 9 would tell you this, it's 3 units left or right from the center, the vertex. And the 16 would tell you I make that box 4 units up. So I put that box in there, a 3 by 4. So I rise 4 and run 3. That's my slope. So this one's a little bit more tricky for the equation of the asymptotes, if it wants the equation of the asymptotes, because I have a vertex and I have a slope. And I use equation of line to solve for that. Do you guys remember doing that? If I have if my center is at 0, 0, and I rise over, let's say, a over b, then y equals a over b x is going to be my equation of my asymptotes. You guys remember doing that? So now I have a center here and I have vertex here, here, but I could rise over run. Let's say my center is at h comma k. I'm going to say my rise is a over b. I use the equation of the point slope, y minus y1 equals my slope, x minus x1, and in this case it's going to be plus or minus the slope. Here, y would also equal minus a over b, because there's 2 of them. You guys remember doing that? In the hyperbola, the center being 0, 0. The asymptote is rise over run, which is very easy, and I have this printed out later on. Very easy when your center is 0, 0. But when your center is HK, you have to take the point of the center and the slope and plug it in that equation. Y minus y1 equals plus or minus the slope, x minus x1. And this gives you 2 equations, which are your equations of your asymptote, where your point is x1, that's your center, h comma k. That's probably the easiest way to go about calculating the asymptotes. It's probably the most difficult thing to calculate the equation of the asymptote. Here we have the center. We have the distance from our vertex is either A or B, depending on if I'm opening left or right or up or down. And then our height is either A or B, depending on which way, right? So here, the slope is actually B over A. I go up B and over A, but I could easily go up A and over B, depending on the setup, right? Here, A is what's under the X term squared, and B is under the Y term squared. But it could easily be this. My slope is A over B here. Here, my slope's B over A. The vertex is always A units from the center. And we have B squared is A squared plus B squared. So you can get away with calling A or B something different and still get C. Right? So if A is under the X term, it's going to be the A unit and move along the x-axis. If A is under the Y term, it's the opposite, right? Like this one here. Right? But for C, you can get away with calling A, B, and BA. But on the ellipse, you can't. A is always the larger one because C is A squared minus B squared. Right? Focus point's always going to be on the major axis. A, if your minor axis or your major axis, or B distance from the center, depending on which is your major and minor axis. Here, the major axis is the x. Here, the major axis is the y. And they always take a to be the larger number. B is the other one, and it's going to be the distance on the minor axis. Then C is always on the major axis, and it's the focal distance, and it's always a squared minus b squared.
Is there an example in this with the slope formula thing?
Yeah. So any of the hyperbolas are going to give you like 2 and 5. 2 and 5 are both hyperbolas. So when I go to graph it, you're gonna identify the key features. This is a hyperbola, so I need to identify the center, the vertex, the focus, and the equation of the asymptotes. Don't worry about whatever. Eccentricity, how circular it is, or how smushed it is. There's not any reason to calculate that. So don't worry about that. E value, which is just A over C, I think. But so if we look at the answer to number 2, that comes from graphing it. The center was at 2, 0. Pretty easy to see from that. The vertices is going to open left or right. And it's going to, let's write this as 2 squared over 9 minus y squared over 16 equals 1. So the negative is in front of the y, so it means I open left or right. So this is really 3 squared, and this is really 4 squared. So this a value is 3, and this b value is 4. So the a means I look on the x-axis, and I go a units to the right. I'm at 2, 0, and I go 3 units to the left, I'm at minus 1, 0. If I go 3 units to the right, I'm at 5, 0. Right? The focus points I have to calculate by taking c squared is a squared plus b squared, and I end up with 16 plus 9, which is 25, so I end up 5. So it means I go 5 units to the left and 5 units to the right of my center. I get my focus points. The asymptotes are probably the hardest thing to do here. So the slope would be 4 over 3, right? I go up 4 and I go over 3. It's really plus or minus 4 over 3. My center is given at 2, 0. So the way I find the equations of the asymptotes, I'm going to write this in here really quick. Plus or minus m, x minus 1, x minus x1. The point is at 2, 0, and the slope is plus or minus 4 over 3. So I have y minus 0 equals plus or minus 3 over 4, x minus 2. You guys see that? Where I plugged in the x component to the x component and the y component to the y1 component. So I have y equals plus 4 over 3 minus 8 over 3. Oops, forgot my x. Or I have y equals 4 over plus 8 over 3. And those are the equations of the asymptotes. And those are the same as up there. That's all you have to do. Once you have the point and the slope, you use point slope form of a line. Y minus y1 equals m times x minus x1. Plug in your point, your x1, y1, and plug in your slope, plus or minus it, and you get 2 equations. Probably the most difficult thing to do with the hyperbola.
Can you write it just plus or minus? Or
Here.
No, where your final answers, how you have it.
Well, one of them's plus and one of them's minus.
Okay, yeah.
So yeah, the plus 1 and then the minus 1, it gives me. So I take, here it's perfectly fine to write plus or minus, but when you go to distribute it, you get two different equations. And similar in this manner, the slope are always plus or minus the same, but the y-intercept is going to be different. Here the y-intercept's minus 8 over 3. Here it's positive 8 over 3. Question?
Could you just really quickly run down how you got 8 over 3?
4 over 3 times 2 would be, if I have positive 4 over 3 times minus 2, gives me minus 8 over 3. If I have minus times minus 2, minus times a minus is positive 8 over 3. That's a good question though, right? Number 5 is also like that. The center in this case is 0 minus 2, and the slope would be up 1, 2, 3, and run 1, 2, 3, 4. Right? So here I have the point 0 minus 2 is 0 minus 2 plus or minus 3 over 4. So I have y minus 2 plus or minus 3 over 4 x minus 0. So this would be y plus 2 equals 3 over 4x, or y plus 2 equals minus 3 over 4x. So the equation of the asymptotes here are a little bit easier to calculate because the x point is 0. If I subtract 2 from both sides, I get this equation and this equation. So really, if you can get the center and get A and B and know which one's the rise and which one's the run, the asymptote's not that hard to find. It's a little intimidating because you don't use that formula that much, because that's really an 040 or 050 to a point of slope, but that's what you're doing. It has to go through the center and have this slope, and one of those slopes positive and one of those slopes negative. Pretty straightforward on that. Being comfortable with it too, knowing, okay, I get the equation on the asymptotes, I know exactly what to do. I have the center, I have a slope, plug it in that equation. You'll get majority of the points even if you do something mathematically wrong, simplifying it. And then the last part that students might struggle on because they're a little disconnected from it is 9, 10, 11, and 12. If I give you information about the graph, find the equation, right? Is it a little, you know, it might not say, actually it's always going to tell you what shape it is. So it's an ellipse, and it tells you the center, and the minor axis has a length. I put my center. Oops, my pen's dying. Center at -1, 5. Minor axis of length 6 and a vertex at -10. Y is not changing, only the x is. So that tells me my major axis is the y-axis, right? If I go up to -10, 5, or in this case down to -10, 5, -10, 5, this distance is 9. Oh, sorry. You're right. Sorry. The x is changing, not the y. This is -10, 5. Right? Distance is 9. So if this distance is 9, this distance has to be 9 for a total of 18. But 9, 9, that's fine. We don't need to know that. This is the x-axis, so that tells me that's the major axis. So I have center is at x plus 1 squared. This would be y -5 squared. Sorry, I don't know why my pen's highlighting like that. I think the battery's. Yeah, looks like So then under the x is going to be 3 squared, which is 9. Sorry, it's actually 9 squared. 9 squared, right? Or 81. 81. Yeah, so it might be relatively easy to see 9. And then it says a minor axis has a length of 6, meaning it's really 3 squared. 3 up and 3 down would be 6, right? The whole, yeah, so if it says a minor axis length of 6, that would equal 1.
When you write it down, do you have to do the 81 and 9? Because Alex actually wrong.
If it puts 9 squared and 3 squared, I'm perfectly happy with that. Yeah. So Alex should accept it as well if you have it squared because it is equivalent. But unless it said, yeah, I don't know why it wouldn't. Yeah. Yeah. Does it say simplify as much as possible? See, that's a debate though, because does it want you to write this as x squared plus 2x plus 1? Because 1 squared is x squared plus 2x plus 1. So if they didn't accept 9 squared in the denominator, I don't know why they would accept x plus 1 squared in the numerator. They say simplify as much as possible. And it's a debate whether this is more simple than this, though. Which is a debate if 9 squared is more simple than 81. I think 9 squared. Yeah, so luckily you don't have a computer grading your test. 9 squared. So practice those and be comfortable. If I tell you, this is a vertex, this is a focus, put it in standard form. Here P is pretty easy to find because P is the distance from the vertex to the focus. What is the difference between the vertex and the focus? 3, right? So here, which way is it opening? To the right? Oh, no, sorry. X is not changing. X is not changing. So I have 4, 3. Yeah. And this is 4. So it's positive, right? P is 3. P is 3. So I have a shift. This would be, the X component is squared. So this would be X plus 5 quantity squared equals 4y minus 3. And that's the equation. A little cleaner. What is this? Number 12. What do I have? That's, I don't know where you got my 5 one. X minus 4. And y minus 3. Yeah, sorry, I was looking at this point. And that's this. All right, so if you don't know if you're not used to doing these, you make them a lot more complicated than they, right? I mean, on the parabola, you just have to find P. And then your shift in your H, your shift in your X direction, your shift in your Y direction is given by the vertex. The same thing, a lot of times they give you the center. So you should be able to get half your points there. The setup, if it's a parabola, only one of the terms is going to be squared. If it's an ellipse, they're both going to be squared and positive. And if it's parabola, they're both going to be squared, but one of them's negative. Sorry, if it's a hyperbola, one of them's going to be, both of them is going to be squared, but one's negative.
So with the 4P, do we even use that on this?
Here we kind of used it because we only found P. So we knew the formula was X minus H, no, Y minus K. So you can leave it as 4 times 3. I'll accept that. But 4 times 3 is 12 too, so it's not that much harder to get it in that form, but it's perfectly fine, yeah. So knowing what to find and putting it in standard form, and I would argue this is just as much standard as A. Just another 4 times P equals A, so it doesn't matter if you have A or 4P. It doesn't matter if, I mean, here, it's funny because here I wonder if they have you solve for Y on one side, on Alex. They do have you solve for Y.
Yep.
They always put it in that form. Even if Y is the one that's squared.
No. If
No.
I'm the one that's squared.
See, that's where I would argue with them. Why don't they solve for X?
I started getting really confused with the way that X pi does
The parabolas.
Yeah,
They're just having
I'm
you
done
go
with-
through
I'm
one.
done
Yeah.
doing the pi. I'm done myself.
Mhm.
It seems like it confuses me more than
Yeah.
So I've just been doing assignments.
Yeah, I don't know why there's such disconnect. If they should accept any standard form. They should accept 9 squared. That's ridiculous.
Right?
Yeah.
You gotta sit there
And
and be like,
then, it told me, I think you've had enough for today. And I'm like, oh.